Okay, we're going to try another application. So this is going to be application number 2. So let's see if we can take a look through on this thing. So the school that Leanna goes to is selling tickets to the annual dance competition. On the first day, the school sold 3 senior citizen tickets and 3 children tickets for a total of $69. The school took in $91 on the second day by selling 5 senior citizen tickets and 3 child tickets. What was the price of 1 senior ticket and the price of 1 child ticket? Okay, so there's our run through. I kind of got a decent idea of this problem. I mean, you're selling tickets. I can kind of see that we're selling 3 senior tickets and 3 child tickets, and we're making $69. I can kind of pick up we're selling 5 and 3, and we're making $91 on that second day. But the catch is, we didn't know what they were actually selling those tickets for. So what we're looking for then is senior tickets price, which I could call X, and the child ticket price, and that would be maybe our Y. So that's what I'm looking for. So I kind of got an understanding of the problem. I know what I'm looking for. I know I'm looking for those prices of those tickets. So I've kind of read through it. I got an idea what I want to look for. Now I need to come up with a plan. My plan a lot of times is, can I just trial and error and see if I can come up with the answer by just trial and error and making up some numbers. So, I'm selling tickets. I know I go to movies and stuff. I've gone to a few dances. Let's say the price of the tickets. Let's just make up some numbers here. Let's see if I have something over here that we can go by. No, don't have anything. I'm just going to have to play this one by ear a little bit. Let's just make up some numbers here. Let's say it's $10 for a senior ticket, and let's say it's $5 for a child ticket. Let's see if this math plays out. So, on that first day, I got to go 3 times 10 plus 5 times 10. I'm sorry. Try it again. So we had 3 times 10, and then we had 3 times 5, didn't we? Let me get that cleaned off there. So I have a 3 times 5. Does that equal the $69? Well, I'm picking up that it's not going to equal it. That's 30 plus 15. I'm falling short on it. That's only 45, isn't it? So I may want to up these prices a little bit. Let's say the senior ticket was maybe $15. So 3 times 15. That's already up to 45. Let's say the child was maybe $7. 3 times 7. Does that equal 69? Well, that's 45 plus 21. That's like 66, so I'm getting pretty close. I'm getting pretty close. I'm like, man, I'm not really getting much luck. But what I'm picking up on, though, is, wait a minute, what am I doing? I'm multiplying the number of tickets by the cost. The number of tickets by the cost. So what I'm picking up on is, why don't I just write the equation? 3x plus 3y is equal to 69, where that's going to be 3 times the cost of the senior ticket plus 3 times the cost of the child ticket. It has to be 69. And on the second day, what we're picking up on is 5 seniors plus 3 child's is going to have to equal $91. So what I'm picking up on is these two equations would represent the information in the problem. So by doing a little bit of trial and error, I'm picking up on, wait a minute, hey, this is my x, this is my y. So why don't I just replace that into my equation? And I'm kind of picking up on, hey, there we go. Notice how these equations are really looking good for elimination, because if I add these together, it looks like these y's would eliminate if this was maybe a negative instead of a positive. And we can come back and rewrite this then as 3x plus 3y is equal to 69. And I can change all the signs by multiplying each side by -1. So negative 5x minus 3y is equal to negative 91. So now I can add these two equations together and I can eliminate the y's. So I'm going to get a negative 2x, and what's a 91 and a 69 there? Looks like 22. So a negative 22 there. So if I divide both sides by -2, x equals then 11. So that tells me that I'm actually going to be buying senior tickets for only $11. So I was in the right ballpark. That 10 was a pretty good guess. What I was really messing up on, looks like, is the child ticket. So now that I found what the senior ticket is, I'm going to substitute the 11 in and find the price of the child ticket. So I'm going to substitute in. So I've got this right here. I'm going to replace that with x in one of these equations. I'm going to just use the top equation. So I have 3 times, then I'm going to replace that 11 in for the x. So it's going to be 11 going here. And so I have 3 times 11 plus 3y is equal to 69. So I have 33 plus 3y is equal to 69. 0 out the 33. 3y is equal to, what's that going to be? Is it going to be a 36? Yeah. Divide by 3. Y is going to equal then 12. So, to solve this problem, what we're picking up on is the senior ticket's actually going to be 11. The child ticket's actually going to be $12. So that's going to be my conclusion. So the senior citizen ticket, the senior price is going to be $11, and the child price per ticket was going to be $12. So trial and error was a little bit of a chaos, but it helped me organize my actual equations. So that's what I sometimes try to do, is pick some numbers, see if it helps me understand the math, and then I can create equations that I can actually manipulate using the strategies that I've learned over the years. In this case, I could use the elimination method as a tool to find my two values. So that's how algebra can be applied to some real-world applications. It can be used, believe it or not. I believe that concludes our lesson on systems of equations. I hope you enjoyed them. Stay tuned for more.